In section 7.3, we are taking all the laws of exponents that we've already learned. We are applying these to rational exponents. So we're really just talking about, on the left side, we've worked with all these integer exponents before. Now we're doing the same thing, following the same rules, but we're working with fractions as our exponents. Okay, so before we do that, let's just do some quick reminders. It is going to be the same rules. You now just have to add, subtract, multiply, and divide fractions instead of integers. But as it is the same rules, I just want to make sure we're all caught up on adding and multiplying fractions. Okay, so if I want to add fractions, I have to make sure I have common denominators. Same goes for if I were to subtract fractions. I have to have the same denominator. Because these are both sevens, what I know is that I can add the numerators together. So 2 plus 3 is 5, and I keep the denominator the same. So we do get 5/7 there. Okay. I like to think about this like if I'm, the same goes if I have 2 apples plus 3 apples, I get 5 apples, right? It goes the same way, right? Fractions are just kind of like your units, okay? So think of it the same way. For number 2, though, I wouldn't be able to add these as they were because we do not have common denominators, okay? This would be like adding apples and bananas, right? You can't do it. So we want to get common denominators. To do this, you're going to multiply by some value to get common denominators. And so if I look at the 5 and the 6, I believe my least common denominator would be 30. So I'm asking myself, how can I multiply to get 30? Well, I'd want to multiply the left fraction by 6, but I can't just multiply by 6 because then I'm changing the value of this whole expression. So if I multiply by 6 over 6, we know that 6 over 6 is just 1. So by multiplying by 1, I'm not really changing the value of this expression, okay? It's going to look a little bit different, but I'm not changing its value. And then same thing here, I'm going to multiply by 5 over 5, because again, I want to get this to be 30, and I want to get this to be 30, okay? If I start simplifying this, we know on the left, 6 times 2 is 12 over 30, and on the right, 5 times 1 is 5 over 30. And so if we add these together, we do get 17 over 30. Okay, sometimes you'll be able to reduce this, but in this case we cannot, so that would be your answer. And then for problem number 3, whenever you're multiplying, it's kind of simple. You can just multiply straight across. So we get 5 times 7 is 35. On the bottom, 3 times 10 is 30. And we know that these are both reducible by a factor of 5, so that would give me 7/6. Okay, so that'd be our final answer. Remember, when you multiply these fractions, you can start reducing right away, right? If I see common factors, so like 5 and 10 reduces to be 1 and 2. And then when you multiply across, 7 times 1 is 7, 3 times 2 is 6. Okay, so usually it's going to be easier to reduce first, like I did in the red, but you can do it either way, up to you. All right, so we're really going to do these same types of problems, just now we're dealing with fractions. So I know for this first one here, x cubed times x to the 4th, I add the exponent, so that's just x to the 7th. So here I do the same rule, I have to add these together. This would be x to the 3/5 power. That's it. Here I know I'm going to have to subtract the exponents whenever I divide powers. So this would be like y to the 9 minus -2, and that's the same thing as y to the 11th power. Here, I'm going to subtract these. So this would be, again, the same thing as y to the 1/2 minus 7/2. Well, I do have common denominators, so 1 minus 7 is -6. So -6/2, well, that's just the same as y to the -3rd. And I can't leave it like that. I need to have positive exponents. So my final answer would just be 1 over y to the +3rd power. All right. I'm going to box these answers so that we can know what our final answer is for all of these. Here we have a power of a power. So I know that for something like this, I need to multiply those exponents. So that would be something like w to the 10th power. 2 times 5 is 10. Here I'm going to go ahead and I'm going to multiply these. So this would be like w to the 2/3 times 9/4. Okay, so I'm going to again use that method where I kind of simplify first just to save myself a little bit of time. So 2 over 4 reduces to be 1/2, and I know that 9 over 3 reduces to be 3 over 1. So if I go ahead and I multiply my numerators together, we get 3 on top. And if I multiply my denominators together, 1 times 2 is 2. So we get w to the 3/2 power, and that would be my answer there. Okay, so really just make sure you're used to and comfortable with adding, subtracting, multiplying, and dividing fractions. That's going to save you a lot of headache here. So let's go ahead and try some of these. We're going to simplify these expressions, again, using all of our laws of exponents. So here I see that, again, when I multiply two powers, I have to add the exponents. So this would be like a to the 1/2 plus 2/3. Well, I can't add these together right now because I don't have common denominators. So 1/2 plus 2/3. That means I'm going to have to multiply the first fraction by 3/3 and the second fraction by 2/2. That's going to give me 3/6 plus 4/6, and that's going to be a total of 7/6. All right, so that means my exponent's going to be 7/6. That's a positive exponent, so there's nothing I can do with that. That is going to be my final answer. Problem number 2. We see that we're dividing two powers. Whenever I divide powers, I subtract the exponents. So this is going to be the same thing as p to the negative 2/5 power minus 3/5 power. Luckily, we do have common denominators, so I know that negative 2 minus 3 is negative 5. So that gives me p to the negative 5/5 power. That does reduce. That's just p to the negative first power. And then we want to make that a positive, so I'm going to move this to the denominator. So 1 over p to the first power. Again, you don't even need that 1 there, so let's just do 1 over p. All right. Problem number 3. I see that this 1/4 is going to need to be applied to both w squared and m to the 3/7 power. Okay, it's not technically distributing, but you can sometimes think of it like that same kind of concept. So if I kind of apply that 1/4 exponent to the w, that would be w to the 2 times 1/4 power, and then m to the 3/7 times 1/4 power, right? That 1/4 gets multiplied by the 2 and multiplied by the 3/7. So if I start reducing, 2 times 1/4, remember this 2 is really in the numerator, it's like 2 over 1. So that'd be like 2/4, and 2/4 is the same as 1/2. So w to the 1/2 power there. And then if we multiply straight across here, we get 3 on top and 28 on the bottom. So m to the 3/28. All right, nothing else we can do there. We have different bases, so I can't combine them. And that's our answer. Problem number 4, okay? Kind of like the first one we did, but now we have 3 of the same base. So I'm just going to go ahead and add these all together. So this is going to be the same thing as b to the 1/5 plus negative 4/3 plus negative 3. I'm just going to add all of these together. And I can't add these together right now because we don't have common denominators, right? I have 1/5 plus negative 4/3. And then if I write negative 3 as a fraction, that's like negative 3 over 1. So they all have different denominators right now, but I do have to get common denominators before I can add them. So it looks like with the 5, the 3, and the 1, it looks like the least common denominator would be 15. So I'm going to multiply this first fraction by 3/3, second fraction by 5/5, and third fraction by 15/15. All right, trying to get common denominators here. So if I do that, we'd get 3/15 minus 20/15 minus 45/15. Okay, I'm now just going to simplify this, right? So 3/15 minus 20/15 is negative 17/15, and we still have a minus 45/15. All right, so we know that negative 17 minus 45 is going to be negative 62/15. All right, this cannot be simplified because 3 goes into 15, but it does not go into 62. 5 goes into 15, but 5 does not go into negative 62. So there are no common factors that I could take out here. So this would be your final exponent. Therefore, final answer is going to be b to the negative 62/15 power. Just kidding. Got to make it positive, right? So we're going to go ahead and we're going to change this to 1 over b to the 62/15th power. Okay, making sure you're listening and actually watching the videos. This is not your final answer. This is your final answer. All right. Problem number 5. Let's go ahead and we're going to have to apply this -9/2 to both the numerator and the denominator, but I personally like to simplify what's inside first. So if I simplify this, I do have to subtract these exponents. That's the rule. So we have d to the -4/3 minus 1/3. I do have common denominators. So -4 minus 1 is -5. That gives me d to the -5/3 power. So really, inside of this, we have d to the -5/3 power, and this is being multiplied by -9/2. Okay, so I'm just going to go ahead. We could think about, oh, I'm going to flip this, and then I'm going to flip that, right, because we have negative exponents. So we could think about the reciprocals, but it might just be easier to multiply these together. So if I take -5/3 and multiply it by -9/2, we should see that -9/3 becomes -3/1. And so when I multiply straight across, we see that -5 times -3 is 15, and 1 times 2 is 2. So we get 15/2. So not too bad. That does save us a little bit of time by using that method there. So we get d to the 15/2 power. Last question, number 6. Now here we have a number as my base. 2 is the base. So I still use the same rule. I'm going to have to subtract these powers here. So we've got 2 to the 5/2 minus a -3/2, right? You subtract the -3/2. So this is the same thing as 2 to the 5/2 plus 3/2. Well, luckily, again, we have common denominators of 2. So if I add the numerators together, 5 plus 3 is 8. So this is like 2 to the 8/2 power. And 2 to the 8/2 power, that does reduce to be 2 to the 4th. And we know 2 to the 4th power is 16. All right, so 16 would be my final answer there. All right, so that is how you're going to use the laws of exponents to simplify any expressions that have those rational exponents, those fraction exponents. Okay, it's all the same rules. Just be careful when you're working with the fractions. Make sure you're adding, subtracting, multiplying, and dividing.